Now we're going to have a very interesting topic on proving identities in trigonometry. First, we have to review our algebra. So we have this Pythagorean theorem here, which states that the square of the hypotenuse here is equal to the sum of the squares of the two legs. Now, in symbols, a squared plus b squared is equal to c squared. That is the Pythagorean theorem. So if we have this equation here, we divide the equation by, if we divide the equation by c squared, we're getting a squared over c squared plus b squared over c squared is equal to c squared over c squared. But in our trigonometry basic identities that we have learned, a over c, and this is our theta for the right triangle, for any right triangle, a over c is equal to sine theta, and b cosine theta is equal to b over c. So this one here, we convert this one, sine squared theta plus cosine squared theta is equal to 1, since we've divided the whole equation by cosine by c squared. Now, if we have this relation here, basic identity in trigonometry, if we divide the whole equation by cosine squared theta, we're going to get sine squared theta over cosine squared theta plus cosine squared theta over cosine squared is equal to 1 over cosine squared theta. But we have also learned that sine over cosine theta is equal to tangent squared theta, tangent theta. So if we square that, we have tangent squared theta plus 1, and this 1 over cosine squared theta is equal to secant squared theta. Now we have another identity, We have derived another identity, and we will go back to this basic identity here. If we divide the whole equation by sine theta, sine squared theta, we're going to get sine squared theta over sine squared theta, excuse me, over cosine squared theta over sine squared theta is equal to 1 over sine squared theta. So sine squared theta over sine squared theta is equal to 1. Cosine squared theta over sine squared theta is equal to cotangent squared theta. And this one here, 1 over sine squared theta is equal to cosecant squared theta. So now we're ready to apply these basic identities in proving some identities in trigonometry. So we're given here 1 over secant squared theta is equal to 1 minus 1 over cosecant squared theta. And we want to prove that the left side of the equation, this portion here, is equal to the right side of the equation here. So we know that 1 over secant squared theta is equal to cosecant squared theta. We're going to work out on the left side of the equation. Well, now we're going to prove this one to be equal to this one. So cosine squared theta, as we derived lately, from this relation here, cosine squared theta is equal to 1 minus sine squared theta. So now we are going to convert cosine squared theta. That will be equal to 1 minus sine squared theta. And that is, and this portion here, sine squared theta is equal to 1 over cosecant squared theta. So we have now 1 minus 1 over cosecant squared theta is equal to the right side of the equation, and we have successfully proved that the left side is equal to the right side of the equation. So for number 2 problem here, we have here cotangent squared theta minus tangent squared theta is equal to cosecant squared theta minus secant squared theta. Now we have proven this one, cotangent squared theta, from this relation here, what's that? Cotangent squared theta is equal to cosecant squared theta minus 1. And tangent squared theta is equal to secant squared theta minus 1. So all we have to do is substitute that derivation here. So we now have cosecant squared theta minus 1 minus secant squared theta minus 1 is equal to the, that should be equal to the right side of the equation. So get rid of the parentheses, so that we're going to get cosecant squared theta minus 1 minus secant squared theta plus 1 is equal to this one. So we cancel minus 1 plus 1 is equal to 0. What remains is cosecant squared theta minus secant squared theta. So again, we've proven this relation here, to the, is equal to the right side of the equation. So this will be our answer. For number 3 problem, we're going to prove tangent squared theta minus sine squared theta is equal to tangent squared theta sine squared theta. First, we're going to work out on the left side, since this is much complex than the right side. So this tangent squared theta is equal to sine squared theta over cosine squared theta, minus the same here, sine squared theta is equal to the same function. Getting the LCD here, we have sine squared theta minus sine squared theta over cosine squared theta over cosine squared theta. The LCD is cosine squared theta. So we now have this equivalent function. We factor out sine squared theta. What remains is 1 minus cosine squared theta over cosine squared theta. And then we separate sine squared theta over cosine squared theta to this portion here, the parentheses, 1 minus cosine theta is equal. So this one is equal to the tangent squared theta. And this 1 minus cosine squared theta is equal to sine squared theta. So this is tangent squared theta times sine squared theta. So we have successfully, again, proven that the left side is equal to the right side. For number 4 problems, we have here 1 minus cosine squared theta, 1 minus cosine theta times quantity 1 plus cosine theta. That should be equal to sine squared theta. So if we multiply these two terms here, we're going to get the difference of 2 square, which is 1 minus cosine squared theta is equal to sine. So this portion here, as you have derived, that is equal to sine squared theta is equal to sine squared theta. For our last problem, cosine theta over sine theta plus sine theta over cosine theta should be equal to cosecant squared theta, secant squared theta. Getting LCD, which is these two functions here, sine theta over n times cosine theta. So this one becomes cosine squared theta, and this one becomes sine squared theta over the function sine theta over cosine theta. Sine theta times cosine theta is equal to, that should be equal to this problem, this portion. So what now? What's next? So cosine squared theta plus 1, cosine squared theta is equal to 1. So what remains is 1 over sine theta cosine theta. And then we separate these two terms here, 1 over sine theta times 1 over cosine theta. And this portion here is equal to secant squared theta. 1 over sine theta is equal to cosecant squared theta. 1 minus cosine theta is equal to secant theta is equal to cosecant theta over secant theta. So again, we have proven that the left side of this portion here, cosine theta over sine theta plus sine theta over cosine theta. Since we have proven that this portion here is equal to the right side equation, so our answer is correct. So that's how we're going to solve similar identity problems in trigonometry. So I hope you've learned something, and thank you for viewing our video for today. And please don't forget to subscribe to my YouTube channel by Will Predotan and click that notification icon. But if you have some problems, suggestions, and comment, please send us your feedback, and we'll gladly address it so that we can improve our presentation. So thank you, and again, and see you later.